Okay, here we go guys with a classic question. We've got monochromatic light directed at a diffraction grating with n slits per unit length, and we want to know what will happen to the angle between the successive maxima and the number of observable maxima when we change the number of slits. Phew, long description. Once you process that, hit pause, try the question, and press play when you're ready to see an explanation. Okay, so for this one, we're looking at diffraction gratings, so we're going to pull up our formula n lambda equal to d sine theta. Lambda is staying the same here, and we are changing the d here. And we're trying to see what happens effectively to n and also to theta. Let's go through it. Firstly, we're going to acknowledge that our d is written in a slightly different way. Okay, we notice here that we've got n slits per unit length. So what this means, for every meter, for example, we've got n slits. So instead of d here, I'm going to put a 1 over capital N. All right, so that's going to be important. Now, the maximum value of n comes when sine of 90, that's the maximum observable angle of diffraction, is equal, sine of theta, sorry, is equal to sine 90, which is equal to 1. Okay, so what you can see here is on our top line, we get a 1. Okay, we're keeping lambda the same. So the maximum n is going to decrease as we increase this value n from n to 2n. In other words, we double capital N, we will have small n. Okay, so we're going to be able to take away a couple of our answers here. We're expecting n to decrease, therefore we're going to have A and C there. Okay, now what about our angle? Well, we come back to sine theta. We can rearrange our equation. Sine theta will bring the n up as n times n lambda. Now we assume that we're on the same n, same lambda. As we increase n, theta will also increase. So that means the angle between the successive maxima increase, and the answer here is A.